So for today, we're going to finish chapter 16. No, sorry, chapter 15, which is the exception. And after that, I try to finish chapter 16. It's about template. So we'll cover ideas such as template, function pointer, and the lambda expression. Those are covered by a few chapters. I will try to get a brief, and then we'll go into the standard template, which is the main thing I would like to cover. So we have been talking about exception. Exception is a way for us to be able to generate more information regarding what's going on with a program, especially a library that's probably written by somebody else. And how do we actually be able to handle what's that situation? And for this, for your homework assignment number 6, we're actually in the document. It says that you're going to use a program called ecs36b exception. .h. So I actually provide the source code. So if you go to the GitHub, the exception, let me see, GitHub is here. Where is my exception folder? Must be somewhere here. Okay. Let's go to repository and then go to exception. And you can see that I have a bunch of code which is updated. For example, GPS.cpp, I have a 2 version of GPS.cpp. One is just the original GPS.cpp, and the other version is actually GPS_HW6.cpp. We will actually compare the difference today. I just want to briefly mention that GPS.cpp was the original version of how do we implement all the function in the previous homework for the reference about how certain concept can be implemented. And GPS_HW6.cpp is a revision from that original code, except using, say, returning some kind of true or false. Is actually throw exception. So it's an exception enabled version of the GPS.cpp, which actually give you the real example about how you can actually follow that to implement your own homework assignment number 6, how that can be done. And similarly, I give you a code, which is, I probably should make it a little bit smaller. You can see I also have a 2 version of ecs36b exception.h and ecs36b exception_hw6.h. And that new version is actually enhanced. You can compare those two. The difference between those two is not that big, but the second one is actually compatible with GPS_HW6.cpp. And also to do the testing, I have actually a new version of ecs36b JSON HW6. And this one is, the difference is I just add a function which actually help you to convert the name, the class name. Remember what is type ID is going to give it to you as a class name. It actually includes some kind of number. There is a numerical number and then the class name. So I actually add another function in the ecs36b JSON_HW6.cpp, which remove that number, which actually give you the real class name for that, the polymorphic object that was created. So it's just a new function. That's the difference. And then the mobility dump, there is another version called mobility dump underscore HW6, which basically testing the capability of those exception for that. Okay, so that's the things that's actually in this directory. Okay, so let's actually take a look at probably the one that's actually here is the it's very simple, but I want to provide some explanation why I need to make some small change there. Let me go to, sorry, this is this one. Okay, I need to go to exception. Okay, this is the code that you should be using to generate the exception for your homework assignment number 6. So it's very, if you look at this piece of code, it's very similar to what you already have, which is class. We define class ecs36b exception, which is a single inheritance from the STD exception. That part should be pretty straightforward. And then we still have the interface. We have this structure. We have this function. This is a virtual function called what. Basically, every single one that's actually inheriting from exception, STD exception, they should have this what. And basically, I will explain a little bit about the implementation of what for ecs36b. And there is a one difference is that I add in line 21 a field called data. And this data are declared to be JSON value. Okay, so essentially, I use a JSON to represent whatever data. This is, by the way, similar to the JSON CPP exception, which is the exception itself is a JSON because it's easier for me to encode any kind of information I want. Okay, so now I want to say, well, what are you throwing? Okay, by the way, the important thing is try to, when you throw about what do you do? So inside the what, you basically say, I just return STD string dupe of this data to style string to the C string. So first I should declare that in the exception, STD exception, the return value of what is a pointer to a C string. The return value is not a CPP C++ string, but instead is a C string. So okay, just take a look at this piece of code. Let me show you the original code, so it might be easier to read from my terminal. Okay, this is the piece of code you can see here. The that is basically the function body for the what. And this code, let me actually tell you that there was 2 different ways I can do this code. First way is whatever I did over there. And the other way, I can actually just get rid of the string dupe. Wait a minute. I cannot delete it? Yeah, I can delete it. There's no problem. Okay, you see that I have a 2 different way I listed here. Option number 1 and option number 2. Okay, so I want to ask your opinion, advice about what's the difference between option number 1 and option number 2, and which one or both of them will work, or neither of them will work, should work. So first, I just want to clarify. Anybody I assume all of you knows about string tube, or actually this is not necessarily a familiar. Okay, all right. So all right, first I have to explain what is a string tube. So I assume you all heard about a function called string copy, right? Have you heard about the function string copy? You have used string copy. So let me ask you a question. When you do string copy, the destination buffer, when you actually try to copy a string into that destination buffer, that's what you do. So when you do a string copy, there is a destination, which is a pointer to string, C string, okay? And then you have the source, which is the also a C string, right? So that is essentially a string copy. By the way, this one is const, okay? One of the things that's actually really tricky about string copy, sometimes we can do string copy, can this two string be overlapping each other? Can this two string be overlapping each other? The answer is a yes. And whenever you have two string, you do string copy, you do overlapping, it tends to happen some kind of error. Okay, just let you know that is very important. But now my question to you is string copy, you have a destination. Who is responsible to actually allocate the memory space for that destination buffer? Is programmer or is the system? When you use string copy, who is actually responsible for allocating the memory for what? It's basically programmer, right? Programmer has to, I mean, how will you allocate memory before, what kind of, can you give us an example that when you try to do string copy, how do you allocate memory?
At first malloc.
Okay.
And then I'd have to use string.
Okay, all right, any other way? Any other way you can allocate memory besides malloc? I can actually statically allocate, right? For example, I can do this. Just want to show you. The two-way, one way is basically doing malloc, and typically malloc is just using malloc. And the second way, I typically just say character buffer. Maybe I declare buffer was 1024. Sorry. Character. I can actually do this as well. I mean, statically allocate some memory. I know this is going to be sufficient to cover that. In fact, when you do malloc, you have to do that as well, right? What malloc you need to do is you have to do malloc, say 1024, because you have to typically figure out how to do that. Okay, so let me ask you a question. Maybe not you, maybe somebody else. When you do malloc, how do you know you have enough bytes of memory being allocated? How do you do that when you do a string copy? How will you do that? Yes. Exactly. So essentially what you will do is you will do malloc, and this is a size of character times string length of, what's your name? Reina. How do you spell Reina? R-E-I-N-A, Reina string. Okay, assuming that's the source. Okay, so by doing this, you see that I actually guarantee size, character, string length with Reina string. Okay, is this correct? Everybody okay? If you do this, if I ask you this question in the final exam, you got 0 point. What was the mistake? You, Reina, and what's your name? Nicholas, don't answer this next question. Somebody else, what's the mistake with this? Yes.
You have to do a +1 for the
Exactly, +1. Okay, I'm refreshing your ecs36b. The string must have a +1. because at the end of the string, there is a one extra character we call terminator, which is the \0. So when we allocate, is always allocate string length plus 1. Okay, that's why. Okay, then that's good, right? This piece of code is essentially malloc size of character, string length, whatever string plus 1, right? All right. Any question? So now this is a way to do string copy. All right, now I'm actually going to tell you what's a string dupe. String dupe is just take this line, do strcpy malloc. I'm going to change this to src. Plus 1, string copy, take 2 argument. Wait a minute. 1 more, comma, src. Okay, this line is called string dupe. Okay, does that make, can somebody actually go over this line of code I just put it here with what I'm trying to do over here? This line. What I'm trying to, yes, please, in the back. Exactly. So basically, I'm doing a memory save string copy, which I actually let the program itself help me do this automatically. So the user is, the programmer is one less things to worry, right? When I do string dupe, it will be going there. So essentially, let me actually see. There must be a manual for string dupe. Okay, so string dupe is basically save a copy of the string. Let me see if they actually show you the code. Yeah, the code, this was a piece of code that is very commonly used. Essentially, is equivalent or almost syntactically equivalent to this one. Okay, so basically you just creating is I will call a memory save version of string copy, and then I use this a lot. Yeah, in the back. Yes. Okay, that's a good. But before we get that, what's your name? Will. Okay, so I have to do after this. I have to do free will string. Okay. Because I know Will will remember to free it. The rest of you, please remember that. Learn this lesson from Will. Because as a malloc, you have to have a free. So whenever you string dupe, you have to free. Okay, here is the other question I want to ask you. What is the difference by doing malloc 1024 versus doing character buff 1024? Obviously, if you ask Will, the second option, you don't need to free, right? If I define a buffer to be 1024, it will not, I don't need to free it, but this one I need to free. But what's the advantage of using malloc versus using this one? Why I don't want to use this one? I didn't want to use this one when I implement that what function exception. Why this one? What's the potential problem with that kind of definition? Yes. It has to do with stack, because when you declare this one, the memory is from stack. And yes.
The buffer variable is stored in the stack, while malloc stores variables in the heap.
Right.
And it's useful especially when using a variable, declaring it within a function and then using outside, because at the end of the function, the stack gets cleared for that.
Right, that's great. What's your name? James, what's your name? Nitin and James, they actually provide a very nice answer to this. And this is important for you to know. If you make this kind of mistake, it's very hard to debug, because the memory that you use, this is what we call static allocation instead of dynamic allocation. So static allocation is actually being allocated on the stack. Whatever on the stack, when the function return, then essentially this memory is basically I will say it's being reused by something else. So it's not guaranteed it will be there. And therefore, anything you do with this, they can only be usable in the same function. And after that function exit, this one is gone. And on the other hand, malloc is actually more permanent. Malloc is in another piece of memory you call heap, which when you exit the function, it doesn't matter. You can still, but the hassle you have to deal with, whenever you use malloc, you have to either call the free yourself or ask for help from Will, and Will will help you to figure out how to deal with that situation. Okay, so now after we actually see this, now we go back to look at this piece of code. So why option 2 is actually not ideal? Because option 2, if I call this data to the style string.cstr, the whole thing, what's the type? The whole thing is a pointer. The whole thing is a pointer, and the pointer basically is pointing to a string that's actually generated not through malloc. It was generated statically within the scope of this function. And therefore, before I return, I actually do a string dupe. You see that this is option 1, and this is option 2. Okay, so this function essentially is almost the same, but the thing is, I believe that particular string will probably be gone. When you call another function on the stack, it will be gone. So therefore, for that pointer, I basically call a string dupe. I generate a copy and then return the address of that string. It's a copy of the string on the heap to whoever want to catch this exception. Remember that this exception to generate is actually deep in the multiple level in some of the other code, which eventually will be catched by some other function outside. So therefore, we have to make sure that whatever information we have there must be there. Okay. All right, this is a declaration. So just let you know how I show you in this code. And I also want to show you that I actually declare a few error code here, -1 to -5, and you can actually modify adding more into that, but I just provide a few, which is sufficient for the demonstration purpose. Okay, so let me actually now go to gps.cpp. Okay, so this gps.cpp is basically the Homer 6 version, which has the exception enabled. So let me actually show you the GitHub first. I just want to show the contrast between the original GPS CPP and the Homer 6 version of. So let's go to. Okay, this is you can see that this piece of code is JSON to object. Okay, which is the original version, which you can see that I did a bunch of check. At the end, I basically write the value to the variable and everything is up. This is the original version. That's the interface. I didn't use any exception, only return true or false. So essentially, you only know from the outside of this GPS that you have successfully or failed, but you didn't know exactly what happened. I mean, which of the 6 conditions I checked actually failing the conversion between the JSON to object. Okay, so that is the original version. So now you can actually, both the code is available to you already. This one is GPS Homer 6. That's actually go down. Okay, is actually a lot longer. It's a lot longer. It's JSON to object. But let's actually first, I actually using ecs36 exception. I actually create an exception object. So essentially, in the exception, we are trying to throw an exception object to hopefully some other program will be able to catch that, okay, to be able to handle that. So let's actually just look at one of the condition. I actually basically implement everything here for this. You can see that there are 6 cases, so I actually have a 6 if then else. Is null, is object, is latitude null, latitude is null, and then double, things like that. I actually have all this being set it up. Okay, so let's actually take a look. And yeah, for example, the first one, if input JSON that is null is true, then I basically say S buffer, the input is a null. I just provide some information, S buffer, and basically I encode this S buffer into the message. And then the error code, I said exe_err input null, which is, where is that? That is actually in here. You see that? exe_err out of range, exe_err input null, that's -2. So essentially, I define a macro for each of the error condition I use. So in this case, I actually not only know what is the type of the problem by description, but I know the error code. All right. And let's take a look at another example. Let's look at, okay. Let's look at this example. Starting line 207, say, if the input JSON is the longitude is null, means that you actually missing an important key value pair that I needed to convert the JSON to the C++ object. So you can see that my S buffer is missing require attribute longitude, and then my message is the S buff, and then the input is then I actually, in this case, I also include the original input as well as one of the encoding, because JSON I can put anything I want there. And then I have an error code saying that exe error missing attribute. Okay, so this actually provide a lot of information to the program or function, try to call this particular piece of code. And you can see that after I encode this JSON to my exception, the next thing I did is I just throw my exception, right? I just throw it, and then instead of return a false, I just actually throw that, okay? So that is how I did the GPS. So I want to see how you actually catch it. It must be in mobility. Mobility dump.cpp. Okay, over here, what I did here is I didn't do JSON to object, but I actually also had a similar setup for the exception for dump to JSON. In this case, I probably should change it to be a little bit consistent with the lecture I just gave. But anyway, I want to show you this part first. You can see that I create a GPS DD called G2. The latitude is 90 and the longitude is 181. What's the problem with this one? Longitude and latitude for this one? Yeah. Exactly. The longitude has to be -180 to +180, which is the latitude is -90 to +90. That's basically cover the whole Earth, right? So so that is essentially it's going to generate some problems. So basically, when I call dump to JSON, it's actually going to capture an exception. And with that exception, you can see that I actually do an exception because it's a virtual function. Whenever I call what, I will be able to see that. Okay, so let's actually try to run this program, and then I want to show you how it works. Okay, so this is the last part. You can see that, okay, I have an error code, which is -1, and the message is a longitude value 181. Is out of the range from -180 to +180. And then basically the method is dumped to JSON. And then the type ID is GPSDD. Okay, so it's basically provide you a lot of information about what kind of error you're dealing with. And so you can actually look at this value or look at this error code, decide how you're going to fix the problem in your program. That is, you can think about it as a debugging or is a way that you can do exceptional handling that way. Okay. Any question regarding exception? Sorry, ecs36b exception.h. Okay, I want to ask you a question. If you don't have a question. So I show you two versions of the code. One version of the code, which is this JSON to object with this exception way of handling this. And the other way is doing the original one, which I just return true or false on this one. I want you to think about that. What's the difference? I mean, I would say I will not, obviously the difference is one is using exception, one is using that. So can you actually think about that? What's the pros and cons about using exception in this particular context? Do you think it's good? Or most likely, most of you probably will say, hey, this sounds good, it provides more information. But what's the drawback about using exception versus the traditional? Yeah, Will. You have to have a try block, yes. And if you don't have a try block, what will happen? It will crash, right? It will generate, say, I generate a exception object, and you actually have nothing to actually catch it, right? I mean, for example, let me show you the example. This is what will happen. If I go to all the way down here, and I just simply copy this code out. I just copy this code outside of the try block. Okay, you see that I moved it up. Let's see what kind of things will happen if I try to run the program. You see that? I'm actually getting this. There is uncaught exception. Okay, if you move it out, it actually will generate that. You will see the abort trap 6 over here. The rest of the message is because I still have another exception. That's why it's caught. But this one is uncaught. So exception, if you want to use exception, you always have to do so, which means that if you use somebody else's code, it might be always safe to write a code looks like this. If somebody else code, you don't know who wrote the code, you just say try and then catch the STD exception. Okay, just assume they're using something which is inheriting from exception like ecs36b. So as long as you have that try clause, then essentially your code will be able to at least not getting that abort trap 6. Okay, what else? Well, what do you see as an advantage of having exception in this case? When we compare the way I show you with that, what's the advantage of using exception? Yes.
part of the more information, it tells you exactly what went wrong. So it said that like 181 was on counts. So it gives more information that you can more easily debug.
Right, this essentially give me the same information like GDB, right? The GDB, I actually be able to realize what's going on. But with GDB or LDB, the debugging information, I don't really realize if you don't have the source code, sometimes you only see what went wrong at a certain level, but you don't know exactly because you lost a lot of information from the source code. But with this type of interface, you actually be able to get more information out. Yeah.
Is using exceptions to have like 3 or 4 functional routines being that can grow and have solutions. Like something to carry that, whereas if you didn't have each function to return that they're
Right. So you basically can handle multiple cases, right? And yes, you want to say something? Sorry, no, never mind. Anybody? Yeah. Anything?
If you have like a larger scale project, and just one small element doesn't affect the rest of it, you don't have to terminate the whole program because something went wrong.
Right. So essentially, exception is giving the programmer still under control. I mean, for example, I'm just giving an example. Nicholas sent me a GPS location, which is out of the range. And so essentially, I know that piece of information is actually wrong. But I still want to say I want to go to Starbucks, and that Starbucks doesn't work. So maybe I will get it from Will to say, hey, what's the other GPS? So the programmer can actually look at this to see exactly which component is wrong. And then I can actually try to solicitate another information. So my program become more robust to some of the input error as well. Because essentially, what I show you this example is input error. And you can actually imagine how easy we will have input error that in today's data driven application. Okay. All right. I hope you got the idea about the trade-off, about exception versus using the traditional way. I feel exception is a really nice tool. But you need to know how to organize your program, how to utilize that information, how to communicate that information. In this case, you can see that you want to use a standard way about using the exception. That's one way to do it is just using std exception and look at the error. But it will be much more powerful if you actually design your own exception, like the way I show you ecs36b exception.h. Because if you develop that way, you can actually create whatever information that's actually going to be valuable for your application in various stage, and such that you actually be able to control your program or let other people interact with your program more powerful. Okay. All right. All right. I'm going to move to the next topic. So I'm going to do this very quickly. So I'm actually covering 3 different places, and I compared to exception, I feel those things are they're still useful. But the thing is that I feel the opportunity you need to do a lot of those is much uncommon than the case of exception. So I try to cover chapter 8 and chapter 9 and chapter 16 very quickly. Okay, so I'm actually going to my plan is go through like this. So first I'm going to talk about function template. And from function template, which is including lambda expression, then I'm talking about a class template. And from class template, then we're going to use the STD template, which is, for example, you'll be using vector and map, those kinds of concepts. They're basically the same principle and to let it happen. Okay, so first let's actually take a look. What do I mean by a function template? So here's an example. I have a template which essentially compare two numbers. Okay, I have a template compare two numbers, but I don't like this because the zoom is actually blocking some of the views. I'm going to move it down a little bit. Okay, now I'm happy. All right. So this is the idea. The green box is what we call a function template. Try to compare two objects or two variables, and in a way that I make it type generic. So you can see that the template, I have two functions. Let's take a look at two functions. One is comparing two integer. One is comparing two double. And you could actually comparing two GPS location or two person or anything. All right. So I have writing the code looks like this. They're actually sharing the same logical structure. And after you've done this so many times, you realize that, hey, I don't really need to develop for each of the data type. I actually have to write the code. Instead, I just actually write a template, looks like this. So let's actually take a look. How do I actually be able to create a template for this two function or more function like this? So I just use the keyword template and then has this template introducer, which is smaller than or greater than. Inside there, this is also a keyword called type name. And then with type T, and which this T is going to be replaced over here. So here you can see that this T, this T is a type, okay? It's a type. So basically say, hey, this function called minima is actually going to return something which is belong to that type. And then the input parameter, A and B, their type is also to this type T. And then inside the function body is return. A is smaller than B, and then A is so if you understand this part, let me show you that. If I want to do the double, when I use this template, after you have this template, I just say minima, min, and then I put double because this double is going to replace this T. So essentially, when you say min double, you actually at that point by the compiler. By the way, this is compiler, nothing to do with the runtime. At the compiler stage, it essentially generates a code using that line from that template. So the template and the instantiation your code is actually going to generate this code. How does that happen? Because the type name T is now double. So essentially I say double min, double A, double B, and return A smaller than B, and then A, yeah, like this, okay? So that is a function template looks like this, okay? Any question with this example? Okay, so yeah. Type passing the type as a parameter to the compiler to generate the code. But see, you have three parameter here in this line. Double is a parameter that's actually going to be consumed by the compiler. And this two number, this X and 2.7, they are parameter to the function that's generated by the template at runtime. So you actually have a three parameter when you look at this. The first parameter between that smaller and greater than is actually the parameter passed to the template itself. Okay. Yeah.
What is the input not the
Say that again. This one? No, it needs that. I just didn't write it down. Yeah, I understand what you're saying. I think you should do this as well. I probably missed it, or actually the default is in, I don't know. I think you need to have this, okay? Okay, so let's actually, as I said, you can actually have GPS DD as well. If you actually put in GPS, if you declare the operator overloading on the smaller for GPS DD, if you have operator loading on this one defined, you can actually do this as well. Okay. All right, so here is a syntax for a template. So you can see that the template is, this is a generic way. So I show you an earlier example. That's kind of very simple, but this is a general, and then I will stop. So essentially the template, you have a type name for T return, type name. You can have multiple type name for target one, for argument one, type name for argument two, and then you can just say T return foo, T argument one, T argument two. And then when you actually call the function, when you actually really call the template foo. So by the way, what's the name of the template? Is a foo. So this particular template takes how many arguments in the template? 3 arguments. T return, T argument one, T argument. You can name anything you want. I'm just using this as a parameter, and you can say foo JSON value star. The second parameter is a person star. The third one is JV time star. That means you actually have a function which will return JSON value and take a 2 argument. The first argument is type person, and the second argument is JV time. Okay, so that is essentially how you actually do this kind of mapping. Okay, I'm going to stop here, and then I will continue this topic on Wednesday. All right.